Okay, so let us begin. So chapter 6, alternating currents. 6.1c, in this chapter, the first things that we're going to look at is how to use sinusoidal voltage and current equation, which is these two equations. I equals to I naught sine omega t, and also V equals to V naught sine omega t. So when it comes to these two equations, there are two types of questions that can be asked. The first one is that the questions will ask you to form equations. So how to form equation? Form this equation. Now, first thing, you have to know which variables they are constant in these equations and which variables they are changes with time. So when you look at these two equations, we have I equals to I naught sine omega t and V equals to V naught sine omega t. The constant variable in this equation is the maximum value, is the peak value, and also the omega, okay, which is the peak value. Now, peak value in our equations, in the I equation is I naught, or in the V equation is the V naught. So meaning that it is the maximum value, okay, it is the maximum throughout the process. And then another constant is the omega, okay, the omega. And then the variable that is not constant, in which we're going to leave it as unknown, okay, when forming equation, is the instantaneous value and also the time. Now, instantaneous value in this equation is the I or V, which changes with time. That's why we say we don't have the value, because at every single moment they have different value. Okay, so I equals to I naught sine omega t, V equals to V naught sine omega t. The questions, sometimes they like to ask us to form equations. Now, sometimes you're not going to use sine in your equations, okay, but most of the time we use sine, okay, because that is the generic equations. But sometimes you have to look at the graph given. Okay, you have to look at the situations given, whether your graph is start from 0 or it start from maximum value. Okay, whether the current is start to flow from maximum or from 0. So the sign here, sometimes you can write it as cos, depends on the graph given. Okay, depends on the questions given. Now we'll go through a few examples after this. So for now, we just have to know what is a constant variable and what is the unknown variable, and also what is the alternating current. Why we want to use the trigo functions in our equations? That is because the current, it keeps changing direction. It keeps moving back and forth towards the two different directions. Unlike your direct current, when it comes to DC, we have current flowing in just one direction. Now, for example, this is our resistor. And then DC, a typical DC is the battery. So battery, when it comes to the battery, the current is just flowing in one direction. Okay, it has just one direction. But when it comes to AC, what happened is that now the current, it keeps changing direction. But of course, the value, it won't straight away reach the maximum amount. It won't reach the maximum value straight away. What is going on right here is that it's going to increase slowly in one direction. And then when it reaches the maximum value, then it will decrease again, and now it moves in the opposite direction. When it goes back to 0, it will start to move in the opposite direction. So it starts from 0, it slowly increase until it reaches the maximum value, for example, in the clockwise direction. And then what happens after this? It will decrease, but in the same direction. Okay, still moving in the same direction, but now it will decrease slowly. And when it goes back to 0, what's happening? Now the current, it will flow in the opposite direction. Okay, so the direction, it keeps changing. So when it comes to DC, what happened? Okay, let's say now I have a VT graph, okay, a VT graph or an IT graph, okay, IT or VT graph. So IT graph or VT graph, when it comes to the DC, what is happening is you have a linear graph. Okay, provided if you have a resistor right here. So you have a linear graph. The value is fixed. The moment you switch on the power supply, the value is fixed. But when it comes to AC, what is going on? Okay, the value, it keeps changing. So either V or I and T. Now let's say you switch it on, it starts from 0. So now this is the shape of the graph. It starts from 0, move in the clockwise direction, increase slowly. When it reaches maximum, while still moving in the clockwise direction, but now it decreases slowly. So when it goes back to 0, what is happening now? It changes its direction. So now it's moving in the anti-clockwise direction, reaches the maximum value, and then decrease in the anti-clockwise directions until it goes back to 0. And after that, it will move in the clockwise directions again. So it keeps changing its direction in the AC current. Okay, so that is the main difference between DC and AC in terms of the graph and also in terms of the directions of the current and voltage. All right, so the directions of current flow, it keeps changing. That's why we call it AC. And when we form equations, now since you look at the graph, it is a sine wave. Okay, it is a sine wave. Therefore, we use sine in our equations. And of course, in some questions, in some situations, they will give you a cos graph. Okay, if you are given a graph like this, then when you form equations, you should form it as a cos omega t equations. Okay, the equations will become I equals to I naught cos omega t, V equals to V naught cos omega t, provided if you are given the shape of the graph like this. All right, now let us go back to the equations again. So just now I told you, okay, the first thing that you have to know is to form equation. Okay, how to form equations? Well, you need to know which one is a constant value and which one is unknown. If it is a constant value, then you need to include the value in the equation. For example, you look at example 1. Example 1, you are given an equation I equals to 2 ampere sine 100 pi t. In this equation, the constant variable is the peak value I naught, which is 2. That's why when you form equation, you need to include the value in the equation. And the omega is also fixed. The frequency of the source is also fixed, which is 100 pi. Okay, this is the omega. So 100 pi is a fixed value, it's a constant variable. Therefore, you need to include the value in the equation. Then how about I and t? Now, since I changes with time, that's why you leave it as unknown in your equation. Okay, even if you are forming the equation, you leave it as unknown. Because you are not given the time, the question didn't tell you, now you are looking at the current at what time. Therefore, I belongs to unknown. Okay, because it doesn't have a fixed value, and the main things is it changes with time. Okay, it changes with time. And the second type of the questions that can be asked is that it asks you to extract information from the equation. Okay, extract information from the equation. Now, what are the informations that you can get from the graph? Well, for instance, the constant value. Okay, you can get I naught and V naught from the equations. And other than that, what is the things that you can get from the equations? Obviously, is the omega, because it is a constant variable, right? Because when you are given an equations, the values of omega is given. Now, why is it important to have omega? Because from omega, you can then calculate frequency and also the period. Okay, and also the periods that you need in the calculations or in the graph sketching. So sometimes, okay, if you're given omega, okay, you need to calculate its frequency if question asks you to calculate XL or XC. Okay, the capacitive reactance and also the inductive reactance. Why? Because the equation, it comes with a frequency. Okay, you have a 2 pi fc or 2 pi fl in the equations. And then how about period? Why is it important to calculate period? Because questions like to ask you to sketch graph based on the information given, based on the equations given. When it comes to plotting or graph sketching, okay, usually you'll be asked to sketch I against T graph or V against T graph. When you're sketching these two graphs, okay, IT graph or VT graph, the information needed, okay, the information that you must have in the graph is the maximum value and also the time taken to complete one oscillation, which is the period. That's why, okay, that's why you need to know what are the information that can be extracted from the equation. Okay, so you can extract the information, extract info of I naught or V naught from the equation, as well as the period. How to get period is from the omega. So once again, when it comes to chapter 6, the things that you need to know is that omega, frequency, and period, they are one big family. If you have one of the variables, if you have one of the value, then you will be able to determine the other two values, right? The values of the other two variables. So that is 6.1. Okay, the things that you need to know in 6.1, how to form equation or how to extract information from the equations. The reasons why we want to extract the information, it is because we want to sketch graph. Okay, or sometimes we need to calculate to solve calculations questions. All right. So now let us go through for example 1. Example 1, an alternating current I is represented by the following equation. So when you are given this equation can be used to calculate instantaneous current. And of course, you can get the peak value from this equation as well. Okay, so by using this equation, you have two information. You can use it to calculate I instantaneous, or you can get the information about the peak value. Okay, the peak currents from the equation. So where time is measured in second. Okay, now why is it important to know what is the unit for time? Because it will tell you the units of omega. If time is in second, then the unit for omega would be radian per second. If time is in minute, then the unit for omega would be radian per minute, right? So it is important to check the unit for time. See whether it is in second, millisecond, or minute, so that you can identify, okay, so that you can know what is the equations, what is the unit for omega, right? So question A, it asks you to determine the maximum current. So whenever you are given the equations, okay, whenever you are given equation, always compare with the general equation. So since you are given I equals to 2 ampere, okay, I don't want to write unit. So I equals to 2 ampere sine 100 pi t. So what are we going to do whenever you're given an equation? You compare with general equation. So I equals to I naught. Now, since equations given is in sine, so we keep the sine in our equation. If equations given is cos, then in general equation, you just write cos. All right, so it becomes I equals to I naught cos omega t if you are given cos in the equation, in the question. So I equals to I naught sine omega t. That is the general equation. So what are we going to do? We just compare. So by comparison, okay, by comparisons, we know that I naught is equals to 2 ampere. So that is the answer for questions A. Okay, so what are you going to do in the exam? You just write down the general equations and then you say by comparison, I naught is equals to 2A. Straight away, you can get full mark. Okay, straight away, you can get full mark. Now let's look at questions B. Questions B asks you to determine the frequency. Okay, so remember frequency, remember the family for the frequency. How to determine frequency. So frequency and omega and the period, they are one family. If questions ask you to calculate frequency, it means either omega or periods will be given. So from these equations, the values that we can obtain from the question is omega is equals to 100 pi radian per second. Okay, radian per second. So from here, we can then calculate the frequency. So omega is equals to 2 pi f. So f is equals to 2 pi, oops, sorry, it should be omega over 2 pi. Okay, omega over 2 pi. But in the value, frequency is then equals to 50 hertz or 50 s negative 1 also can. All right, so it is up to you whether you want to use s negative 1 or you use hertz. Both are correct. Okay, both are correct. So that is how you solve questions B. You try to find the families of frequency. So who is belonging to the same family, who is coming from the same family, either the omega or the period. So when you do comparisons with the general equations, straight away you can obtain omega. Therefore, we use omega in questions B. Okay, therefore we use omega in questions B because that is the information that you can obtain from the equation straight away. Now let's look at question C. Question C now asks you to calculate current at a particular time, which is the instantaneous current. So now you are given the time. So what can you do? You just plug in the time because now it tells you, Okay, you are going to determine the current at times t equals to 2.5 millisecond. So you plug in this value into the equation, then you will get the values of I at that particular moment. So I is now equals to 2 sine 100 pi. So times given 2.5 millisecond, 2.5 times 10 to the power of negative 3. Now remember, when it comes to this type of question, the mode of your calculator should be in a mode radian. Okay, because you are not given degree, so this one is radian. You are looking at the angular frequency. So remember, the mode of your calculator should be set into radian. So plug in the value and then just use your calculator to solve it, and you should obtain I equals to 1.4 ampere. Okay, I equals to 1.4 ampere. So when it comes to questions 2, okay, C2, now it asks you to calculate the current at times t equals to 12.5 milliseconds. So what are you going to do? You just repeat the same step. Plug in the value, okay, plug in the value into the equations given, and you should obtain a negative value now, which is 1.4 ampere. Okay, I is now equals to negative 1.4 ampere. So this is your instantaneous current, the current at a particular time. So what is the time? The time is given. Okay, questions 1, time is 2.5 millisecond. Questions 2, time is 12.5 millisecond. All right, so now I give you a few minutes to write down the summary for 6.1 and also the questions for the answer for example 1. Okay, I'll give you a few minutes to write it down before we proceed to example 2, where we are going to learn how to sketch graph based on equations given. Okay, so example 1 is quite simple. Basically, we just learn how to use the equations, how to extract the information from the equations. Now, let's look at questions. Oops. Let's look at example 2. Okay, example 2. Now, you're going to sketch graph. Okay, based on the equations given. So, how are we going to sketch the graph? So, questions A, I equals to 2 sine 0.5 pi d. The first things that you should do is try to compare with the general equations and see what are the informations that we can get from this equation. So I is equals to I naught, since you are given sine here, so we keep it sine omega t. By comparison, I have I naught equals to 2 ampere, and then I have omega equals to 0.5 pi radian per second. Okay, 0.5 pi radian per second. Now, when it comes to this type of question, if you are not given the unit, then you don't have to include its unit. Okay, but if you are given the unit, then you should include the unit. Okay, most of the time questions will give you the unit. It will give you the equations, and it tells you where I is in terms of ampere, and then omega or the time is in terms of second. Then from there, you should be able to identify the unit. Okay, now this question, because there are some missing info, so if you didn't write down the unit, then that's fine. Okay, but usually questions will tell you what is the unit for I, and then what is the unit for time. So from time, you can then identify the unit for omega. Okay, so now if you look at this information, you have I naught, which is the information needed, okay, when it comes to graph sketching. And then you have omega. What is the reasons the questions give you omega? Remember, it is for you to calculate period. Because when it comes to I against T graph, okay, when it comes to IT graph, the information that we need to have is the maximum value and also the time taken to complete one oscillation, which is period. So period is equals to, okay, so well, we have omega is equals to 2 pi over t. So t is equals to 2 pi over omega. So omega is 0.5. So 2 pi divided by 0.5 pi. So we have t equals to 4 seconds. Okay, we have t equals to 4 seconds. So that is the information that we obtain from the equations given, okay, by comparison with the general equations. Okay, so I have I naught equals to 2a, I have t equals to 4 seconds. Now I can proceed to graph sketching. So questions A, okay, questions A. So I have I against t. Okay, so assuming I have I in terms of ampere and t in terms of second. So what am I going to do? After I've sketched it, after I label the axis, okay, what should I do? I go back to my questions. Now I have a sine graph. Okay, I have a sine graph. And then, well, according to this equation, it starts from 0 because there's no initial phase angle. What does it mean by initial phase angle? Well, you can look at questions C and D. Question C comes with a minus pi over 2. Questions D come with a pi plus pi over 2. It means the graph, it does not start from 0. Okay, it does not start from 0. It starts at an initial phase angle. But when it comes to questions A, there's no initial phase angle and you have a sine function. Therefore, we know that the graph is start from 0. Okay, then you just sketch it according to the shape of a sine graph. Right, a sine graph. Okay, so what are we going to do next? We need to label the maximum value. So according to the information that we extracted just now, we have I naught equals to 2. So here is -2. And of course, don't forget about the 0. And the time taken to complete one oscillation is 4 seconds. So done. Okay, that is a complete graph. That is a complete answer for questions A. So first step, you compare the equations given with the general equation. And then by comparisons, you should be able to obtain the maximum current, the I peak, and also the omega. From omega, you then calculate the values of period. okay, because we need it in our graph. We need to label the values in our graph. So questions A done. Now let's look at questions B. Questions B, okay, as usual, we're going to compare with general equations, but how to compare? Now let us begin with I equals to I naught. But since now you're given a cos function, so in my general equations, I'm going to write it as cos omega t. Okay, cos omega t. So again, by comparisons, I have I naught equals to 2 ampere, and then I have omega equals to 0.5 pi radian per second. From omega, I then obtain t equals to 4 seconds. Okay, so I have I naught, I have omega now, then I can proceed to sketching. So again, I against t graph. Okay, remember the unit in terms of amperes and second. Now you look at the equations. Now equations tell you should have a cos function. Okay, and there's no initial phase angle. That means you can keep the original shape of the cos graph. So a cos graph, the shape, it looks like this. Okay, so that is the shape of a cos graph. Okay, so what I'm going to do is a bit short. Okay, let me make it a bit longer. All right. So now I have a cos graph. Okay, as a cos graph, as usual, I'm going to label it. So here is 2, here's 0, and here is -2. And of course, don't forget a period, which is the time taken to complete one oscillation. So 4 seconds. So now that's it. That is the answer for questions B. You see, it's very simple, right? You just compare the general equations with the equations given, and then you extract the maximum value and also the omega from the equations. And from omega, you then determine the values of period. Once you have period, you can then plot the graph. So how to plot the graph? First step, okay, you need the axis. Okay, you need the axis. So x and y axis. The second step, you look at the shape. Okay, you look at what is the shape of the graph. So this is the second step, the graph. And then the last step is the label. Okay, third step is the label. So from axis, and then you sketch the shape. Okay, you have the shape of the graph. And lastly, you label the information that you obtain from the equations given. Let's look at question C. Okay, how are we going to solve questions with initial phase angle? Well, as usual, we are going to compare with the general equation first. So I equals to I naught sine omega t minus 5, right? So I have I naught equals to 2 ampere. I have omega equals to 0.5 pi radian per second. From here, I then obtain t equals to 4 seconds. And by comparisons, I know that my graph is now start at -pi/2. Now, when it comes to this type of questions, okay, instead of graph shifting, like what we did in a SEM 1, well, I think it will be easier if you try to look at the phasor diagram. Okay, so it tells you have a sign here. All right, and that -pi/2 means it starts from somewhere that is -90 degrees, okay, behind the sign. So sine by right, it should start from 0. Okay, so let us say this is our x component, this is our y component, this is 0, 90 degrees, okay, or pi/2. Okay, pi/2. This is pi, this is -pi/2. So if you have sine graph, it means your graph, it should start from here. Okay, it should start from here. But because it tells you now initial phase angle is -pi/2, then from 0, you move backward by pi/2. So it means now your graph starts from -pi/2. So when you do projection, okay, when you do projections of the graph from the phasor diagram, from the circular motion to I against t graph, it shows you that now your graph is to start from negative maximum. Okay, so if you start from negative maximum, then what are you going to get? You're going to get an inverted cos graph. Okay, inverted cos graph. So that is the answer for question C. So again, this is the unit, this is the time, and then you label it. This is 2, this is -2, and here is 0. And the reasons why I know it starts from -2, that is because according to my phasor diagram, okay, if I have a sine graph, it should start from 0. But because of -pi/2 radian initial phase angle, so I move backward by pi/2, which means now I should start from here. Okay, I should start from here. Now, if you are given cos with an initial phase angle, then you start from the maximum value and then see whether you want to move backwards or you want to move toward a positive pi/2. Right? So for me, I think that is a trick in how to solve it, how to sketch the graph. Okay, for me, I think it will be easier if you do projection from the phasor diagram. So you look at the questions, since you are given sine, now sine initially is to start from 0, but because of -pi/2, so we move backward by -pi/2. Okay, so which means now your graph is going to start from negative maximum. So that is the answer for question C. Then how about questions D? Okay, questions D, well, again, if you do a comparison, what are you going to get? You're going to get I naught equals to 2a, and then you will get omega equals to 0.5 pi radian again, which means now period is equals to 4 seconds, but the initial phase angle is now positive pi/2 radian. So let's say now you have a phasor diagram again. Okay, 0, pi/2, pi, -pi/2, right? So original equation given is sine. Sine by right, it should start from 0. But because you have initial phase angle, positive pi/2, so now it moved. Okay, you move it. It means you're going to start from plus pi/2 position. So you're going to start from here. Okay, this would be your initial point. So when you do projection, okay, when you do projection, what are you going to get? It means your graph is now going to start from maximum value. Okay, so if you complete the graph, then you will see that it's actually equivalent to a cos graph, same as the questions B, the shape of the graph. So now after you plot the graph, as usual, label everything. Don't forget. So this is your period 4. This is 2. Here is -2, and here is 0. Okay, so you start from positions that is positive 2. So which means when I equals to 2 cos 0.5 pi t, it's also equals to 2 sine 0.5 pi t plus pi/2. They are equivalent. Okay, they are equivalent. These two equations from B and equations from D, they are equivalent to each other. So, okay, done. Okay, so I have questions A here. I have the answer for questions B, answer for questions C, and also the answer for questions D, right? So this one, I give you 4 minutes to write down the 4 graph, okay, to sketch this 4 graph. So 4 minutes for you to write it down, then we will proceed to next subtopic. If you have any question, if there's anything that you don't understand, you may ask. Right, so I hope you know how to sketch a graph. Now, of course, the fundamental shape, I believe all of you know how to sketch already, the A and B. Okay, just take note on how to sketch the graph for question C and D. Okay, so when you have a negative pi over 2, well, actually, you just start from a negative pi over 2. Okay, it means that your graph starts from the bottom. Okay, so if you have a positive pi over 2, then you're going to start from a 90-degree. Okay, it means that your graph starts from a 90-degree. All right, so now let us look at example 3. Okay, next subtopic. So next subtopic, we have a root mean square value. Okay, so in this subtopic, what you have to know is just how to apply these two equations. So quite often, questions will give you either one value, either the maximum value or the RMS value, but they ask you to determine the other one. Okay, they ask you to determine the other one. And then VRMS equals to V naught over square root 2. And this is also the effective value. And by default, if the questions didn't mention the values given belongs to which one, okay, whether it belongs to instantaneous value, peak value, or root mean square value, then we assume, okay, we assume they are all root mean square value because that is the effective value. So example 3. Example 3, now you have an AC source where V is equals to 500 sine omega t. So you are given an equation. Whenever you are given an equations, okay, like this, then what should you do? Always compare it with general equation. So V is equals to V naught sine omega t. This is the general equation, okay? So it's connected across a resistor of 250 ohm. So this is the R. Calculate the RMS current and the RMS voltage in the resistor. So how are we going to calculate? It's very simple. Let's look at the equations given. Equations given, V is equals to 500 sine omega t. By comparison, okay, by comparisons, we obtain V naught is equals to 500. Okay, by comparisons. So V naught is equals to 500 volt. That is your peak value. That is a peak voltage. So from peak voltage, you can then determine the root mean square value by using VRMS equals to V naught over square root 2. Okay, so which is equals to 500 over square root 2. So VRMS is equals to 353.55 volt. So once you have VRMS, you can then calculate IRMS by using VIR. Okay, remember, I and V, they must be coming from the same family. So if you want to calculate IRMS, then you need to use VRMS. So VRMS is equals to IRMS times R, okay, VIR. So as you can see here, V and I, they are coming from the same family. So plug in the value and rearrange the equations, then you should obtain, okay, this is VRMS over R. Your IRMS is equals to 1.41 ampere, okay, 1.41 ampere. So that is the first method that can be used to solve this question. How about second method? Okay, now if you don't want to calculate IRMS by using VIR, okay, by using VRMS, what you can do is you can calculate I peak by using peak voltage. Okay, by using peak voltage. So V naught is equals to I naught times R. Okay, I naught times R. So what you can do, I naught is equals to V naught over R. So remember, I and V, they are coming from the same family. Okay, so this one, your I naught is then equals to 500 divided by 250, which is 2 ampere. So once you have I naught, you can then calculate IRMS by using IRMS equals to I naught over square root 2. Also can, okay, also can. You're still going to get the same answer. So it is up to you whether you want to use the first method here or you want to use the second method. Both are accepted, okay, both are correct in your exam. So it doesn't matter which one you want to use. You can even calculate IRMS first and then apply VRMS equals to IRMSR to calculate VRMS. Okay, so that's what I meant. You can calculate VRMS by using IRMSR. So it is equals to 1.41 times 250, which is equals to 353.55 volt. Also can, okay, it is up to you which one you want to use, which combination you want to use, right? So semua kombinasi Anda boleh guna. Okay, you can use VRMS in the red color and IRMS in the orange color. You can use both in the red color. You can use both in the orange color. Okay, or you can use, you can use any method. Okay, you can use any method as you want, any combinations that you want. So that is questions A. Okay, questions A, you have two methods. Okay, you have two methods. And then how about questions B? Well, questions B asks you to calculate peak current. Okay, so after you obtain IRMS, let's say, after you obtain it by using the red color method, then you can calculate I peak by using this method. Okay, by using I naught equals to, by using I naught equals to IRMS over sub 2. Okay, oh, sorry, not divide. It should be times. So IRMS times sub 2. Okay, you can calculate it by using this method. Okay, from a question's red colored solution. So it is equals to 1.41 times sub 2, which is equals to 1.99 ampere. Okay, 1.99 ampere. Or, okay, this is method 1, or you can use this method to calculate it. Okay, this is method number 2. Okay, this is method 1, this is method 2. Method 1, and then this is method 2. All right, so you have quite a lot of way to solve it. Okay, I'm just showing you all of the method. It is up to you which one you want to use. All right. So now I give you 3 minutes. I want you to write down everything. Saya nak kamu catat semua cara. Sebab apa? Sebab dalam exam, okay, Anda kena tahu semua cara. Okay, Anda kena tahu semua cara. Alright, so I give you 3 minutes. You write down all of the method. But in the exam, it is up to you which combo you want to use, which solutions, which method you want to use. But right now, since you're still in the learning process, make sure you know all of the possible solutions. All right. Okay. So in this few example, I'm going to show you all of the possible solution, and I want you to write down all of the possible solutions, okay, as a learning process. Kalau tidak, nanti kamu keluar, kamu tengok cara. If you look at the difference method, then you are stuck. You don't know why are they doing like this. You don't know the reasons. Okay, you don't know how they can solve it like this, and so on. All right, so I'm going to show you all of the possible solutions, and I want you to write it down as part of the learning process. Okay, example 4. Okay, example 4, now you're given the graph. So figure show a graph to represent alternating current passes through a resistor of 10 kilo ohm. Okay, so you are given R equals to 10 kilo ohm, and then you are given a graph. So basically, you are just going to do a reverse process. Just now, you identify, you calculate I naught and period in order to sketch a graph. Now from graph, okay, the information that you can get is the maximum value and the period. Okay, bila Anda buat sketching, Anda memerlukan dua maklumat ini. Bermaksud bila Anda diberi graph, Anda boleh dapati dua maklumat ini daripada graph yang diberi. Alright, so basically you're just doing a reverse process. Okay, so by looking at a graph, okay, by looking at a graph given, the first information, the first things that we can get is I is equals to 0.02 ampere, the I naught, okay, the peak current. The second piece of information that we can get is the period. But what is the values of the period? If you look at the graph, okay, don't fall into the trap. 80 is not the period. If you look at this graph, you have two cycles right here. Okay, but if you recall, what is the definitions for period? It is the time taken to complete one cycle. Okay, so meaning that 80 is not period. That is not the values that we want. By looking at this graph, okay, one cycle is actually from 0 until 40. This is one cycle. Okay, this is one cycle. Meaning that 40 is period. So T is equals to 40, but check the unit. It's not second, but it's in terms of millisecond. So 40 times 10 to the power of -3 second. So by looking at this graph, the information that I can extract from the graph is I peak is equals to 0.02 ampere. Period is equals to 40 times 10 to the power of -3 second. So now the question asks me to calculate RMS current. So RMS current, since you have a peak value, okay, you have a peak value, straight away you can determine IRMS by applying equations. I naught over sub 2. Okay, so IRMS equals to I naught over sub 2. Okay, 0.02 divided by sub 2. So you have 1.41 times 10 to the power of -2 ampere. That is the IRMS. So once you have IRMS, you can then determine VRMS. Okay, you can then determine the VRMS by using VIR. Okay, so make sure your I and your V, they are coming from the same family. Okay, both of them, they are coming from RMS family. So plug in the value. Eventually, you should obtain V equals to 141.42 volt. Okay, 141.42 volt. Now, of course, since you have I peak value and you have R, okay, you have I peak and you have R, you can also calculate V peak first. Okay, you can also calculate V peak first and then calculate VRMS. So V peak is equals to I naught R. Okay, which is then equals to 0.02 times 10 times 10 to the power of -3. And 10 to the power of 3. Okay, not -3, K. Right? So we then have V maximum equals to 200 volt. So from peak value, you can then calculate VRMS equals to V naught over sub 2, which is then equals to 141.42 volt. Right? So that is another method that can be used to calculate VRMS. Okay, so first method, second method. Okay, first method and the second method. And then questions B. Questions B asks you to calculate frequency. So how to calculate frequency? Remember, frequency, omega, and period, they are one family. In order to calculate frequency, try to ask yourself, do you have omega? Okay, apparently no. Okay, then do you have period? Yes, because from the graph, we obtain period T is equals to 40 times 10 to the power of negative 3 seconds. Okay, so by applying equations F equals to 1 over T, okay, we then obtain frequency equals to 25 hertz. Okay, frequency equals to 25 hertz. So that is the answer for questions B. Okay, that is the answer for questions B. So now I give you a few minutes to write it down before we proceed to a new subtopic. Okay, 6.3. Okay, so write it down first. Write down all of the informations here. Okay, and especially how to obtain period from the graph. Okay, kenapa saya tak guna 80, kenapa saya guna 40. Semua itu Anda kena tahu. Okay, pastikan Anda tahu macam mana analyze graph. So I give you a few minutes to write it out before we proceed to example 5. All right, so far it's still quite simple. Now let's look at next subtopic. Next subtopic is I would say it's the main dish of chapter 6. Okay, everything, the most important things, they are all in this 6.3. So 6.3, resistance, reactance, and impedance. So define and use capacitive reactance, XC, inductive reactance, XL, impedance, and also the phase angle. So you need to know these 4 equations. Well, these are the most fundamental things, the equations that you have to know. And of course, in order to apply to calculate the impedance and also the phase angle, I would encourage you to sketch the phasor diagram. So even though the question didn't ask you to sketch phasor diagram, I always encourage my students to do so that you can see what is going on, so that you know how to solve the questions. All right? So the things that you have to know in this chapter, the first thing, well, I remember I mentioned it quite a few times in the lecture. which is don't get confused between XC and C. XC is capacitive reactance and C is capacitance. That is the first thing. The second thing, don't get mixed up between XL and L. XL is inductive reactance and L is inductance. So they meant different things. Okay, they refers to different things. So XC, XL, CL. So the relationship between these four variables is very important. Don't get confused, don't get mixed up. And then the second part in this subtopic is that you have to know we have 6 different types of circuit. First one, we have pure R, okay? And then we have pure C, and then pure L, RC circuit, RL, and RCL, okay, RCL. So by looking at the question, the first thing that you should do is to identify the questions belongs to which type of a circuit, okay, whether they are pure R, pure C, pure L, or they are a mixed circuit, which is RC, RL, or RCL. From there, you then sketch a phasor diagram. Phasor diagram for every single circuit, okay, phasor diagram for every single circuit. Once you have phasor diagram, it shouldn't be an issue for you to determine the phase angles and also the impedance as well as the source voltage. Okay, so you can then determine, okay, the impedance and then the source voltage and also the phase angle by looking at the phasor diagram. All right, so that is a quick summary for 6.3. The complete summary, the complete table, the complete phasor diagram for this 6 circuit, you may refer to your books, to your lecture notes. So now let's look at example 5. How are we going to solve example 5? First thing, remember the things that I told you just now, you try to identify whether it belongs to which circuit. So now you have a capacitor has an RMS current of 21 milliampere at a frequency of 60 hertz when RMS voltage across it is 14 volt. According to these questions, you have only one component, which is capacitor. So obviously, these questions, example 5, is a pure C circuit. Okay, pure C circuit. So when you have a pure C circuit, what does it mean? Well, it tells you the RMS voltage across this capacitor. So this is your VC. Okay, and this VC is a RMS value. Okay, because it tells you the RMS voltage. Now, even if it didn't mention RMS in the questions, by default, you should know it is a RMS value. And then you're given the current right here and also a frequency, which is a 60 hertz. So what is the capacitance of the capacitor? Now, if you look at this question, the information that you have is IRMS and VRMS. And what you do know is that this is a pure C circuit. What does it mean by pure C? Pure C is, okay, it means, okay, when you apply VIR equation in this circuit, it will become V equals to IXC. Okay, when it comes to a pure circuit, R you replace with XC because now you have just one component. If you have more than one, then it becomes VIZ. So since you have a pure C circuit, we know that V is equals to IXC. Okay, and according to the questions, you have IRMS and VRMS. They are both coming from the same family, meaning that now you can use it to calculate inductive capacitance. Okay, capacitive reactance, sorry. Okay, you can use it to calculate capacitive reactance. So VRMS is equals to IRMS XC. Now, why I want to determine XC first? Because the questions want capacitance. In order to calculate capacitance in chapter 6, we need XC. Okay, we use XC to calculate C. We use XL to calculate L. So XC is now equals to VRMS divided by IRMS. Okay, over IRMS. Plug in the value, then you should obtain XC equals to 667 ohm. Okay, 667 ohm. So once you have XC, you can then calculate C by using XC equals to, okay, if you look at the learning outcome, you are given the equation 1 over 2 pi FC. Okay, 1 over 2 pi fc. So rearrange the equation, you should obtain C equals to 3.98 times 10 to the power of negative 6 farad. Right? 3.98 times 10 to the power of negative 6 farad. So that is how you solve questions in chapter 6. Okay, you try to identify the type of the circuit, and then you look at the information that you have. So since these questions you have IRMS and VRMS, straight away you can calculate XC by using both values. Now, of course, you have to be extra careful with the RMS voltage. Okay, sometimes RMS voltage, given it does not belong to the capacitor, maybe it belongs to the source. So if it belongs to the source, then you have to be extra careful with the type of circuit. Okay, when it comes to these first 3 type of circuit, okay, kalau kamu ada 3 type circuit, pure circuit, okay, then VRMS, okay, V source, okay, V source, it's equals to their value, their RMS, okay, it is equals to VR, V source is equals to VC, V source is equals to VL, if you have pure circuit. But when you have a combination circuit, okay, then you have to be careful. So VS is no longer equals to VC, it is not equals to VL, it is not equals to VR. That's why I told you it is very important to identify the type of the circuit before you solve the question, so that you know, okay, whether the voltage belongs to which part, whether it belongs to the source, whether it belongs to the resistor, capacitor, or inductor. Kalau kamu tak identify, then Anda akan keliru, especially when it comes to V source. Okay, sometimes questions will give you V source. So whether V source can be used to calculate XC, XL, R or not, it all depends on the type of the circuit that you're looking at. Kalau pure punya, then yes, you may use V source. But if it's not a pure circuit, if it is a combination circuit, then what are you doing? What you can do is to identify the Z first, or you can calculate by using a phasor diagram. Okay, we'll go through that type of questions after this. Okay, sekarang kita cuma a brief intro untuk tahu apabila, okay, bila kita boleh guna VS, bila kita tak boleh guna VS. Okay, bila V itu kita boleh guna untuk komponen yang diberi dengan source, bila kita tak boleh guna untuk komponen dengan source. Okay, so that is a quick summary. So this one is a pure C circuit, therefore V source is equal to VC. Okay, V source is equal to VC. Kalau bukan pure, then they are not equal. Okay, so questions 1A or 5A, example 5A done. Now let's look at 5B. 5B, actually, I don't encourage you to do it like this one, like the answer scheme given. What I want you to do, I want you to write it in a equation form, okay, in equations form. So if frequency is increased, will the current in the capacitor increase, decrease, or stay the same? So you are given a capacitor, a pure C circuit, okay, then it tells you, it asks you what happened if frequency increased. So which equations contain frequency? Obviously, it's equations of XC. So FC equals to 1 over 2 pi FC. Now, according to the questions, you are still using the same capacitor. The things that you change is the frequency of the source. That's it. You are not changing the capacitor. You are not modifying the capacitor. Meaning that C is a constant value in this equation. So by looking at these equations, what we can tell is XC is inversely proportional to F. Since 2 pi is a constant value, capacitance is also a constant value in this situation. Because you are not modifying it, you are not changing the physical structure of the capacitor. So XC is inversely proportional to frequency. So when frequency increase, when F increase, XC decrease. Okay, XC decrease. So that is the first part. Okay, that is the first part of the questions. So the first statement, the capacitive reactance is inversely proportional to the frequency. So the capacitive reactance will decrease if frequency increase. I want you to write it down in an equation form. Okay, because usually in the exam, I would encourage my students to write it down in the equation form so that you can see the step. Okay, isn't that this is the 4 step I've been telling you guys? Step number 1, we state the equation. Okay, state equation. And then step number 2, we look at the relationship between two variables. Well, in this case, we're looking at the relationship between XC and F, and then tell what happens, okay? Tell examiner what happens when one of the variable changes. Okay, so what happened? Okay, what happened when one of the variable changes? So in this case, what happens to XC when F changes, when F increases? Because according to the questions ask you what happened when frequency increased. So when frequency increased, XC decreased. Okay, and then step number 4, answer the question. Oops. Okay, step number 4, answer the question. So now can I answer the questions by just looking at the capacitive reactance? Obviously cannot, because question is asking for current. What happens to current when frequency increase? So basically what are you going to do? You just try to look at another equations that we can use to explain what happens to the current if XC changes. So just now we look at what happens when frequency changes. When frequency changes, XC changes. So now we want to see what happens when XC changes. What is the equations that can be used to show the relationship between XC and I? Now, obviously, it's VIXC. So in these questions, okay, provided if we're still using the same source, kalau kita masih guna source yang sama, then V is a constant variable. So if V is a constant variable, then what we can do is, okay, now let me rearrange the equation. XC is equals to V over I. So if V is constant, now XC is inversely proportional to I. So according to the previous equations, previous relationship, now XC drops. If XC drops, what happens? I will increase. Okay, I will increase. So that is how you answer the question. Okay, you just repeat the 4-step recipe here again. So just now, step 1, step 2, step 3. And then you repeat step 1, step 2, step 3 again. At last, you answer the question. What happens to current when I increase? So step number 4, okay, step number 4 I have right here. So when F increase, okay, when F increase, I increase. That is the meanings of answer the question. Okay, answer the questions. So don't stop at this step. Okay, don't stop at here. Actually, this is incomplete solution because you are not answering the questions yet. Okay, you need to answer the questions. So questions ask you what happens to the current if frequency increase. So you answer it when F increase, or if F increase, then I increase. Okay, jangan macam jawapan yang diberi di sini. Actually bagi saya ada incomplete sebab Anda tak jawab soalan. Okay, Anda tak jawab soalan. So kembali kepada soalan, kamu kena jawab apabila frequency increase, apa yang terjadi kepada current. So kalau frequency increase, current juga increase. That is the answer. Okay, that is the answer. So you see, I answered this question by using 2 equations only. Okay, I start from XC equations and then I go to VIXC. So from there, I then answer the questions. When F increase, I increase. So basically, I'm just following this 4-step recipe. Okay, I'm just following this 4-step recipe. So 4-step recipe ini dia sangat berguna apabila kita menjawab soalan explanation. So you try to look at one equation first, try to identify the equation that can be used to explain the relationship. Then you explain what is the relationship between 2 variables. And what happens if one of the variable changes. After that, you answer the question. Go back to the original questions and answer it. Okay, that is your step number 4. So question C, calculate the RMS current if, okay, in the capacitor, if now the frequency is 410 Hertz. Okay, if frequency is 410 Hertz. So what we can do right here, Well, since we are still using the same capacitor, meaning that C is still equals to 3.98 times 10 to the power of negative 6 farad. Okay, it is still this value because you are still using the same capacitor without changing its physical structure. So you have C now with a new F. So F new, okay, I'm going to call it F new frequency is 410 hertz. You can then combine these two, use these two pieces of information to calculate new XC. Okay, so XC depends on frequency. If frequency changes, then XC changes. So XC equals to 1 over 2 pi F new C. Okay, so XC is then equals to 97.5 ohm. So once you have it, you can then calculate VRMS by using IRMS XC. Okay, or VRMS is a fixed value because you're still using the same voltage, same source, you are not changing the source. So IRMS is equals to VRMS over XC. It is then equals to 0.144 ampere. Okay, 0.144 ampere. So that is how you solve question C. Okay, that is how you solve question C. So now I give you 5 minutes to write it down. Okay, because this one includes a bit of summary, includes a bit of how to solve explanations questions. Okay, involve how to solve explanation questions. So I give you 5 minutes to write it down. Okay, 5 minit bagi Anda catat, especially questions B. Okay, questions B, I want you to answer it by using equation instead of statement. Alright, kita guna equations, kita belajar tengok equation. So, questions B, walaupun sudah diberi jawapan, saya nak Anda tulis semula. Ikut 4-step recipe yang saya bagi Anda. So, 5 minutes for you to write it down. Okay. So I hope you're still with me, okay, because you need to understand all this basic before we proceed to the combination circuit. Okay, I go through a bit slowly because I want to make sure all of you understand. Now, example 6. Example 6, now you're given a RMS voltage of 12.2 volt with a frequency 1 kilohertz. Okay, you're given a frequency 1 kilohertz and it's applied to a 0.29 millihenry. So this is your inductance L. This is a frequency and this is a VRMS. Okay, so it's applied to an inductor. So you are given an inductor. Now, if you look at this question, example 6, we have just one component, meaning that this example 6 is a pure L circuit. Okay, pure L. So even though the root mean square voltage here given is your Vs, but because it is a pure L circuit, so Vs RMS is equals to your VL RMS. Okay, because the source voltage is the ones that we can manipulate and control the frequency. Okay, so this one is a source voltage, but since you are looking at the pure circuit and they are all being connected in series, therefore V source is equals to VL in this example. So what is the root mean square current in the circuit? Okay, you want to calculate root mean square current. So VRMS, it's equals to, now do I have a current? Well, I don't have the current. Okay, I want to calculate current. So IRMS, okay, RMS current, that is unknown. And then, well, since it's a pure L circuit, means XL. Do I have XL? Well, right now I don't have, but I know I can calculate XL. Why? Because I have frequency. Okay, so whenever you're given frequency, actually, it is a hint, I would say. It asks you to calculate XC or XL. You need it. Okay, you need the equations, XC and XL equations, because you are given frequency. And then you are given inductance, which is L equals to 0.29 mH. So from here, we can calculate XL by using 2 pi FL. All right, so you plug in the value. Eventually, you should obtain XL equals to 1.82 ohm. All right, so plug in the value. Let's go back to the equations, VRMS. So VRMS is the 12.2 volt equals to IRMS 1.82. So IRMS is then equals to 6.7 ampere. Okay, 6.7 ampere. So from here, we can proceed. Okay, we can go back to the equations VRMS. All right, so IRMS is 6.7 ampere. Questions B. Determines the peak current for a frequency of 2.5 kilohertz. So now you have a new frequency. Okay, so remember the things that I told you just now. When you have a new frequency, it means that either you have new XL or new XC. Okay, new frequency will give you new XL and new XC. Then how about L? L is still the same because you're still using the same inductor. You are not changing the inductor. So let us calculate the new XL. So XL is now equals to 2 pi FL, but this F, okay, this F is no longer 1 kilohertz. Now we're going to use 2.5 kilohertz. Okay, 2.5 times 10 to the power of 3. And then L, you can still use 0.29 because you're still using the same inductor. So XL, the new XL is now equals to 4.56 ohm. Okay, 4.56 ohm. So once you have it, you can then calculate the peak current. Okay, but how to calculate peak currents? We need peak voltage. Okay, initially we just have the RMS voltage. So VRMS is equals to V peak over sub2. So V peak equals to sub2 times VRMS. All right, then you should obtain a value. Right, you should obtain the value 12.2 times sub2. And then from here, we then apply V naught equals to I naught XL. So make sure they are coming from the same family. Okay, make sure they are coming from the same family. So I naught is equals to V naught over XL, which is then equals to 3.78 ampere. Okay, 3.78 ampere. So that is how you solve it. Okay, that is how you solve it. Now, of course, you can you can use another method. Okay, you can calculate IRMS first by using VRMS. Boleh juga, tak ada masalah. Okay, so this one, second method. Okay, method 2. So once you have XL, you can then use VRMS equals to IRMS times new XL. Okay, so from here you obtain IRMS. Okay, you can obtain IRMS right here, which is, okay, this one is a, yeah, let me rearrange the equation first. So VRMS over XL, which is then equals to 12.2 divided by 4.56. Okay, so that is your IRMS. And then you apply equations I naught equals to IRMS cert 2. Okay, eventually you will obtain 3.78 ampere as well. Okay, you obtain 3.78 ampere as well. So the method, the way you can use to solve questions B, okay, you have two different methods. Both will give you same answer. Okay, both will give you same answer. Either you can use the one in the green color or you can use the one in the blue color. And of course, I want you to write down both. Okay, I want you to write down both. So always remember, when you apply VIX, then V and I must be coming from the same family. Okay, so again, I give you 3 minutes to write it down, and then we'll look at example 7 and example 8. All right, so now let's look at example 7. Okay, example 7 is a very interesting question. Okay, and you need to know how to sketch phasor diagram. All right, when you have a pure circuit. So a voltage V represented by equations. So now you are given some equations, okay, sine functions right here. So V equals to 15 volts sine 377t is applied across a pure capacitor of capacitance 200 microfarad. So first things we know about these equations, this question is that this is a pure C. Okay, a pure C circuit. The second thing that we know about this circuit is we have equations V equals to 15 volts sine 377t. So always compare with the general equation. V equals to V naught sine omega t. And now, when you are given these equations in a pure circuit, what I want you to do, I want you to sketch phasor diagram. Okay, kalau kamu diberi equations ini dalam pure C, pure R, atau pure L circuit, then always sketch a phasor diagram before you solve the question. So you look at these equations, now you have V, and it is a sine function. Means that now your V is lying on the X component. This is the VC. Okay, this is VC. And remember, when you have a pure C circuit, which one is leading, which one lags behind? Okay, now a trick to remember, a trick to memorize which one is the leading, which one lags behind. I teach you a phrase. Okay, I'm going to call it Ellie, the Iceman. Okay, I like to use this phrase. Why? Because it tells me which one leading, which one lags behind. So if you look at this phrase, I have L in the alley, I have ice, I have C in the ice. Okay, so why is it important to have this phrase, to remember this phrase, Ellie the Iceman? Because it tells you the positions of the EMF and also the current. Okay, the E here actually stands for, okay, I'm going to assume it's EMF. So L is inductor. Okay, L is inductor, C is capacitor. So E right here is EMF, or in another words, you can say it is a V. And then I here, of course, is the current. Okay, it's the current I. So we have V and I in both here, okay, in both works. So Ellie the Iceman, in Ellie, you see V is in front of I. It's located in front of L and I is behind L. In this case, what does it mean? Okay, in this case, in this part, it means now your V leads I. Your V is in front of I. Okay, and then when it comes to I's, ICE, I is in front of C, E is behind C. So in this case, what does it mean? It means your I leads V. Okay, so since example 7 is a pure C circuit, okay, it is a pure capacitor circuit, meaning that now the current, it should lead the voltage. If current leads voltage and my VC is lying on the X component, where is my I? So I should be pointing upwards, because in a pure C circuit, according to I's, my I should lead V. Okay, I leads V. So this is the omega. So that is a phasor diagram for example 7. Okay, for example 7. So VC is not always pointing downwards. If you look at the summary table, usually we assume I lying on the X component and VC is going down. That is the usual case in the example, in the summary table, in the lecture notes, in the revision books. But that is not always what happened. Okay, dia bukan sentiasa berlaku begini. Dia terpulang pada equation. It depends on the equations given. So since equations given right here, it tells you now your V should be lying on the X component. It should start from 0 degree. Therefore, my I should be located at a 90 degree. Okay, it should be pointing upwards. So jangan sentiasa ingat yang hijau punya sahaja betul sahaja. No, not necessary. Okay, not necessary. It depends on which one is leading, which one lags behind. So your VC, according to the equations given, it should be lying on the X component. So I leads V in a pure C circuit. Therefore, my I is pointing upwards. That is a phasor diagram for example 7. Okay, that is a phasor diagram for example 7. So A voltage represented by the equations V blah is applied across a pure capacitor of capacitance 200 microfarad. Determine the RMS voltage. So by comparisons, when you compare equations given with the general equations, you have V naught equals to 15 volt. From this value, you can then determine VRMS by using V naught over sub2. Okay, therefore it is equals to 10.6 volt. That is your RMS value. Questions B, by comparisons, I have omega equals to 377 radian per second. Okay, 377 radian per second. So since you want to calculate frequency, okay, omega equals to 2 pi f, rearrange equations, f equals to 2 pi over omega. Okay, so plug in the value and eventually you should obtain 60 hertz. Okay, 60 hertz or 60 as -1. And then how about question C? I have the, wait, yeah, 10, oh yeah, it's correct, 60 hertz. Okay, now let's look at question C. Question C, the capacitive reactance of capacitor. Capacitive reactance, okay, it means it's asking for XC. So XC is equals to 1 over 2 pi FC. Okay, so plug in the value and eventually you will get 10.6 ohm. Okay, 10.6 ohm. That is how you solve it. And then questions D, the RMS current flowing through the capacitor. The question is asking for IRMS. And you have a pure C circuit. When you have a pure C circuit, well, very simple. It means your VRMS is equals to IRMS XC. You have VRMS from questions A. Okay, so 10.6 equals to IRMS times 10.6 ohm. So IRMS is then equals to 1 ampere. Okay, 1 ampere. Now, questions E. Questions E is the main reasons why I told you you must have phasor diagram in your questions, even though the question didn't ask you to sketch the phasor diagram. Now, it asks you to form an equations representing the current. You need to know where is the current, whether it is lying on the X component, whether it is going upwards or it is pointing downwards, in order to decide whether you're going to use sine, cos, negative sine, or negative cos in your equations. So according to my phasor diagram, on the right-hand side, my eye is pointing upwards. Means that when you plot the graph, okay, this is my phasor diagram. Okay, when you project it to a sinusoidal waveform, your eye starts from the maximum value. So the shape of the graph is actually a cos graph. If you have an IT graph, okay, if you do projection, so it starts from maximum value. So you have a cos functions right here, meaning that the general equations that you're going to use to form equation for I is I equals to I naught, not sine, but cos omega t. Okay, cos omega t. So it is equals to, well, I maximum. Do I have I maximum? I don't have I maximum, but can I calculate I maximum? Yes, I can. I maximum is IRMS cert2. Okay, so cos omega given 377, so 377t. So plug in the value, I is equals to cert2 cos 377t. So that is your equation. That is your answer for questions E. Okay, that is your questions. That is your answer. The equations for questions E. So how to determine whether you want to use cos or sine? You look at the graph. Okay, you look at the phasor diagram. So according to the phasor diagram, my I start from maximum. So if my graph starts from maximum, then I'm going to obtain a cos graph. So cos graph, I use cos function when I form equation. All right, so phasor diagram is very important, even though the question didn't ask you to do so, but I always encourage my student to sketch a phasor diagram in every questions. Okay, in every questions. So now I give you 5 minutes to write it down, okay? Because I want you to write a bit of notes for yourself. Sendiri buat sedikit catatan how to answer questions E, especially questions E. Okay, this is a very good questions because it tells you the importance of phasor diagram. It tells you the importance to know which one lags behind, which one leading, right? So 5 minutes for you to write it down. Sendiri buat sedikit catatan untuk soalan E. Kenapa saya guna cost? Macam mana saya dapat cost? Dan sebagainya. All right, now let's look at example A. Example A is very similar to example 7, But now you have a pure inductor circuit. Okay, so now let's look at the questions. A voltage V represented by the equation. So again, you are given an equations. So whenever you're given an equations, remember, always compare it with general equation. So V equals to V naught, given sine, so sine omega t. It's applied across a pure inductor. So now you have a pure inductor circuit. Okay, so pure inductor, now remember the phrase, LE, E is in front of I, means now you have V leads I. Okay, V leads I in a pure inductor circuit. So of inductance 200 millihenry. Determine the RMS voltage and so on. Now before that, let us sketch the phasor diagram. Okay, so whenever you learn the equations like this in a pure circuit, then I always encourage you to sketch a phasor diagram first. So once again, you are given V in terms of sine. So it means your V is lying on the X component, the 0 degree. Okay, this is your VL. But according to a pure inductor circuit, you have V leads I in a pure L circuit, meaning that now your I should be pointing downwards. This is the I in a pure L circuit. Okay, and of course, omega is still pointing in the, rotating in the anti-clockwise direction. So V leads I in a pure inductor circuit, pure L circuit. So that is our phasor diagram. Okay, that is our phasor diagram. So questions A, calculate the root mean voltage. So by comparison, I have V naught equals to 10 volt. So VRMS is equals to V naught over sub2, which is then equals to 7.07 volt. The frequency of the voltage, again by comparisons, I have omega equals to 314 radian per second. So frequency and omega, remember, omega equals to 2 pi f, rearrange equations, f equals to 2 pi over omega. Therefore, it is equals to 50 hertz. Okay, 50 hertz. The inductive reactance, so inductive reactance, XL. XL equals to 2 pi FL. All right, so plug in the value and eventually you will get 62.8 ohms. The RMS current flowing through the inductor. So since you have a pure circuit, again, you have a pure inductor circuit. So VRMS is equals to IRMS XL. Okay, this is a pure circuit, therefore we use XL. So rearrange the equations. You have IRMS equals to VRMS over XL, which is then equals to, okay, plug in the value, it is equals to 0.113 ampere. Okay, 0.113 ampere. Now let's look at questions E again. Okay, questions E again. Now I ask you to form equations representing current. So let us go back to phasor diagram. This is the phasor diagram. Okay, on the right hand side, this is the phasor diagram for pure inductor circuit. If I do a projections again onto an I against T graph, now my I, it's a start from negative maximum. Okay, so this is the shape of my current in a pure inductor circuit in a given questions. Okay, meaning that according to this shape, I have an inverted cost function. Cost yang terbalik. So what am I going to do with an inverted cost function? So now my I is equals to negative I naught cos omega t. Okay, because terbalik, negative cost. Okay, negative cost. So I equals to negative I naught cos omega t. Okay, so from questions D, we can then calculate the I maximum, which is a 2 times IRMS, okay, and then cos omega 314t. Plug in the value, you will obtain I equals to negative, okay, negative 0.16 cos 314t. Okay, so the answer given right here is wrong. So that is the correct final answer. Okay, that is the correct final answer. So this is how you solve it. So again, I naught is sort to IRMS. Okay, that is how you obtain, how you expand equations. So basically, that is how you solve example 8. Very similar to example 7, but now you have pure inductor, where in pure inductor circuit, we have V leads I. Okay, V leads I. So you need to know which one leads, which one leading, which one lags behind. And when you have a pure R circuit, then what happened? If you have a pure R, then they are in phase. Okay, V and I, they are in phase. They are pointing towards same direction. So if V is sine, then the I is also sine. If V is cos, then I is also a cos function in a pure resistor circuit, pure R. All right. So yeah, write it down. Again, I want you to make a note for yourself in the questions E. Make sure you know how to answer questions E. All right, because I think it's a past year question. So you need to know which one leading, which one lags behind. You need to know whether you want to use cos, negative cos, sine, or negative sine when you are forming equation. Okay, when you form equations.